Hello everyone, welcome to a new mini course. This mini course is part of a series dedicated to the IGCP 667 project, which is the World Map of the Origins, sponsored by UNESCO and International Union of Geological Sciences. This short lecture is an overview of the Famatinian Origin, an event that occurred in the western margin of Gondwana during Paleozoic times. In this mini course, we are going to identify the rocks related to this origin that appears throughout South America, and we will take a closer look at those that are exhumed in Colombia. Let's start with some important concepts. In the Wilson cycle, there are two well-known processes that create orogens. These are the subduction zone and the collision of continents. During a subduction zone, the orogen resulted is called accretional orogen, while the orogen from the collision of two continents receives the name of collisional origin. An accretional orogen happens in a convergence zone when an oceanic plate sinks below a continental plate. This process generates the rise of magma to the surface, which creates a chain of volcanoes along the border of the continental plate. The origin resulted from this is called magmatic R. There is another way to create origins in a subduction zone. Some crustal fragments are transported by the oceanic plate and amalgamated to the continental plate, which generate high levels of compression and a subsequent origin. We recognize this fragment because they have very different geological characteristics compared with the surrounding areas and are called Aloctinosterones. So, how to know the duration of a paleo-subduction? Well, if a subduction zone existed in the past but is no longer active, we can know the duration of the paleo-subduction by looking at the divergence of the deformation, which will be in the opposite direction. For example, imagine this is the east and this is the west. When there is a subduction to the east, the deformation resulted from that compression will have a westward divergence. The other type of origin is the collisional origin, which is the final step of the Wilson cycle. The Wilson cycle finished with the collision of two continental plates and the closure of oceans. The deformation resulted from this collision brings to the surface rocks that have been exposed to conditions of higher pressure and temperature. Those rocks are represented by these symbols, and these rocks are known as high-grade metamorphic rocks and come from deep parallels of the crust. This also happens when there is an amalgamation of aloctinosterones. Knowing this, let's start with the Famatinian origin. During the early Paleozoic, there is a high mobility of the plates which generates subduction, convergence, and a lot of magmatism, something similar to what occurred in the Cretaceous times. In the early Paleozoic, the Proton Margin of western Gondwana remains an active margin, as we can see in the paleographic reconstruction of the Cambrian and the Ordovician periods. This margin favored the formation of a subduction-related magmatic R known as the Famatinian origin. This orogenic cycle was defined by a Señor Los Santos cell in northwestern Argentina, where we can find the type locality. The time span to the vent that formed this magmatic R is generally accepted to be Cambrian to Middle Ordovician. To get an idea of how the Famatinian magmatic R was formed, we should first reconstruct the Proton Margin of western Gondwana. For this, we have to recognize that exists a large number of accreted terrains that make out this margin, and some of them were accreted or amalgamated after the Famatinian event. In those cases, we remove them. The first terrains that we have to remove are those that were accreted in the northwestern part, this one that are right here. These ones are oceanic in origin and collided during Mesozoic and Cenozoic times. Then we have to remove Patagonia, which is considered an Aloctinosterones, a fragment of crust that was formed away from the continent and that collided during late Paleozoic. Finally, the Proton Margin of Gondwana will be made up of Paleozoic rocks that intrude the metamorphic basement formed during Proterozoic times. In the first image to the left, we can see that the current west margin of South America encompasses several aquatic terrains. Some of them were aquatic during Paleozoic. The type locality of the Famatinian Origin is located in northwestern Argentina, just right here in the Sierra Bambianas. The accretion of the Cuyana terrains west of the type locality resulted in a subduction-related magmatic arc that was active from 490 million years to 460 million years, with a magmatic peak at 470 million years. The igneous rock of the magmatic arc were in place in a metamorphic basement of low pressure and high temperature. The magmatic arc continued in the eruptive belt of Puna, located north of the type locality, just right here. These igneous rocks have been divided into two volcanic belts, the eastern and western eruptive belts, which both show a weak arc signature. In the eastern eruptive belt, two phases of intrusion have been identified. The first one at 465 million years and the second one at 444 million years. The first one is related to the main activity of the Famatinian arc, and the second one is assumed as a reactivation of a weakness zone controlled by extension or transtension. We will come back to this later. It has been interpreted that the geochemistry characteristics of the eruptive belt of Puna come from and are related to plutonianism and volcanism. Now, in this slide, the crustal weakness zone that gave rise to the second intrusion phase of the eruptive belt of Puna is better appreciated. This zone has been interpreted as a greenville suture between Pampa or Amazonian terrain and Arequipa and Antofalla terrains. The suture was not only activated during early Paleozoic, but there are gabbros from the same zone with Neoproterozoic ages, evidence of various times of reactivation. It is also important to note the emergence of the deformation to the west of the suture, where there are Paleozoic volcanic rocks that were found during the subduction zone. The divergence, as you can see it, is to the west, which tells us that the Paleosubduction direction was to the east. Further to the north of the eruptive belt of Puna, the Ordovician rocks appear in the Antiplanar Domain, which is formed mainly of sedimentary rocks. The igneous rocks with early Paleozoic ages are closer to the continental limit. This rock has been interpreted as the continuation of the Famatinian magmatic arc, and the proximity to the coast could be a consequence of crustal erosion by subduction. The previous location, all that we saw before, make up the southern sector of the Famatinian arc, which, according to the description given above, have two different tectonic evolution. On one hand, the Sierra Pambiana sediments to the south, shows lower crustal rocks because of the collision of the Cuyana terrains against western Gondwana margin. And on the other hand, the Altiplano Domain preserves clastic deposits of an Ordovician ritual platform. This was the basin of an arc developed along the continental margin that did not record any collision. In the central sector of the Famatinian arc, it can be found the Vilcabamba Cordillera, which is right here, which is formed of granites with Famatinian ages and low-grade metamorphic rocks. These rocks are in green schist facies. Further to the north, in the Marañón Massif, the Famatinian magmatic arc has been identified. The geochemical data of the rocks found here show a typical arc-related signature, and the metamorphic grade of the basement rocks corresponds to amphibolite facies, amphibolyphaceous are high-grade metamorphic rocks. These descriptions favor the interpretation of a paleosubduction zone and the later collision of the Paracas terrain to the west of the Marañón Massif. Now, the northern sector encompasses the Famatinian rocks of Ecuador, Colombia, and Venezuela. To the south of Ecuador, a segment with Ordovician sedimentary and low-grade metamorphic rocks has been identified. It is known as the Almost Loja domain. This domain is thought to be formed during a subduction zone to the north of Ecuador in the Cordillera Real. Some highly deformed Paleozoic rocks have been identified. However, it is still uncertain if there are remains of the Famatinian origin, which means that more studies should be done in this section. Further to the north, we found the Ordovician rocks in the Santander, Quetame, Floresta, and María massif. These massifs are located in the Eastern Cordillera of Colombia, which is right here, and the Mérida Andes of Venezuela. The basement of the Eastern Cordillera has been interpreted as an Aloctinosterones that was accredited to the Gondwana Proton Margin by the end of the Ordovician. The Quetame Massif is composed of low-grade metamorphic rocks, which the formation has been interpreted as a result of the accretion of the Aloctinous chipchat terrain. The Floresta Massif exposed low-grade metasedimentary rocks, which have been interpreted as part of the Greenvillian Aloctinous terrain. The basement of Colombia and Venezuela belong to the same terrain and have a Greenvillian edge. This northern Andes basement was affected by an important Ordovician metamorphism. The peak of the metamorphism have recognized in amphibolyphaceous at 489 and 472 million years. Now we will see an outcrop in the Quetame Massif, just right here. These rocks are of the Quetame group and have been identified as metaconglomerates and phyllies from pre-Devonian times. Those are low-grade metamorphic rocks that possibly record the collision of the chipchat terrain. Now, the tectonic evolution of Northern South America during Ordovician times is more difficult to understand. That is why the segment of Colombia and Venezuela has been divided into two different domains. To the south, the Quetame domain made up of this rock with lower metamorphic grade, and to the north, the Santander Mérida domain with orthogneises of Famatinian edge. To understand the geological evolution of the northwestern corner of South America during the Ordovician, it has been proposed a reverse paleosubduction zone, it means to the west, based on the vergence of the deformation of the terrains and the position of the magmatic R. The paleosubduction zone to the west will have formed the continuation of the Famatinian magmatic R in Colombia and Venezuela. The subsequent collision to the arc against the continent will have exposed the lower crust that appears in the Santander Mérida domain. Summarizing, the Proton Margin of South America has been an intermittently active margin since late Proterozoic times, and this has affected the tectonic evolution of the continent. The subduction zone formed during early Paleozoic generates a accretionary orogeny that has been called Famatinian Origin. It is important to note that the subduction zone is almost continuous and in the same direction from Argentina to Ecuador, but in Colombia and Venezuela, there is evidence of a reverse subduction zone. The take-home message is the regional character of the Famatinian origin. From María Andes in Venezuela to Sierra Pampeanas in Argentina, this accretionary orogeny is exposed in subduction and collision-related rocks. It is also important to mention that although there was a continuous subduction zone, the tectonic evolution throughout South America during the Ordovician is different in different segments. Well, these are the resources used to carry out this presentation. And finally, about the presenter, I am María Paula MARROQUÍN Gómez. I am a geoscientist from Los Andes University of Colombia. Right now, I'm a researcher at the Servicio Geológico Colombiano in the Mapa Geológico de Colombia group. And the current project that we are working on is called the Geological History of Colombia book. I would like to thank you for your attention and to the IGCP 667 project for this opportunity.